Hello, everybody. Oh. Hold on, everybody. Yeah. Good. Hello, everybody. How's everybody doing out there today? Hope everybody's doing good. I'm good. All right. I gotta lower that a little bit with my hand. distracts me. All right. Good afternoon, everybody. Hope you lovely people are doing amazing out there today. I'm doing pretty good. Doing pretty good. All right. So, yesterday was pretty funny. We broke, well, I managed to break CML a couple times yesterday. If you guys didn't catch the stream, what it was is I was attempting to, and I might have been doing it wrong. I still haven't looked into it yet to see if I was doing something wrong. I might have been doing something wrong. For all I know, I'm not so bright sometimes with stuff. But yeah. So what I was trying to do yesterday was, I was making, I was creating Ethernet channels, Ethernet channels, and turning them into routing ports. All right, and then what I was attempting to do is connect those to another switch. All right, create VLANs on that other switch. On that other switch, and I can't say other too many times because that's kind of confusing. So, I guess let's just fire up CML and take a look. See, I didn't get it fired up yet. My bad. My bad. Oh, I need some coffee, guys. I don't have any coffee. I don't have any coffee. Hey guys, I'm super pumped up. I'm at 44 followers so far, guys. Hold on, I get 6 fingers, not 5. 6 followers away. You guys are so awesome, dude. Thank you all very, very much out there. I appreciate the love. You guys are all amazing. Yeah, so I'm super pumped up about that. We're almost there, guys. We're almost there. I can smell it in the air. Give me coffee though. The best part of waking up is some coffee in me cup. This cup of me tastes like bleach. It doesn't. Deep coffee though. Oh. Let's log into CNO. It does taste weird though. I don't know why. Somebody poisoned me coffee again. All right. This is not Packet Tracer. Well, hello out there, everybody. All right, let me fix this. We're not using Packet Tracer today. Header. Hope everybody's doing good out there. See anybody chat it up. Alright, let's go modeling lab today. Alright. Before I break my scene. Alright. So, yeah, it looks fine. Okay. Alright. So, what I was saying, so yesterday in this lab right here, was EpicPen. EpicPen. See if it's broken. Oh, it's not broken, surprisingly enough. So yesterday, this right here, this layer 3 switch, we were using this as a well, yeah, we were using it as a layer 3 switch, obviously. What we had created was this this line right here, we created an Ethernet channel, so we used two 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 interfaces, put them into a Ethernet channel to a port, created a port, turn those into a routing port, okay? And once you do that, this switch now, this port now acts as a routing port, so you can think of it as a router because it then all the frames that come into that port, okay, are not, they're all going to be hit with layer 3 logic, not layer 2 logic, okay? So that's what we created on this distro switch here, okay? What kept on, and it happened in the first lab I did, okay? And I thought it might have been something with how I did everything, so I repeated it in this lab. And what had happened, I gotta turn this off. When I created VLAN, so I created a VLAN 10. I created a VLAN 10 over here. So this was a VLAN 10, and this was a VLAN 20. You guys have seen me do this 1,000 times, okay? But what was happening was after I created those on this switch right here, I was using the same type of logic and thinking. I was going to say, okay, well, if this is now a routing port now, I should think about it as like a router on a stick type of topology where I would create sub interfaces onto that actual port, okay? So, and it allowed me to do that, and I created sub interfaces off of that port, okay? Because what I wanted to do was I wanted some way to trunk, okay, to the multiple VLANs that I had over here, okay? And it worked. So I was able to create sub interfaces off of that port interface, off that Ethernet channel that I had created on this distro switch that was going down to this main switch right here, okay? And I don't know, I'm going to try it again today, and that's the first thing I want to do. I want to try it without using PAGP, port aggregation protocol, okay? I want to try it without using that or LACP, because I don't know if it was the dynamic-C of that protocol that was breaking this lab. But what would happen was when I said, okay, I want this just on this switch right here, on this port, on this Ethernet channel, I want this to be a trunking port. All right. Once I did that, the distro switch crashed every time. It crashed every single time. It was without fail. It would just crash. And again, I don't know if that was the dynamic protocol that I was using. Today, though, what I want to do is I want to do it again, but without using LACP or PAG or anything like that, to see if that's what was breaking it, if it was the dynamic C of it trying to maybe, I don't know. Again, it might be above like where my level is, but it was just kind of epic. Every time I was like, okay, I was like, I had on the keyboard, should I press trunk, boop, and then this distro switch would explode into a million pieces. So it was pretty epic. And my whole thing though is there has got to be a way to do that. There has got to be a way to do that. And what I'm finding, it wasn't talking about it in the book. You know, it in the, okay, and you guys, I mean, if you follow this before, you guys know that I'm using the official cert guide there for all of my educational needs, which is awesome. I mean, it has pretty much everything you'll ever need in it to pass the CCNA course. but it wasn't mentioning anything about trunking over a routed Ethernet channel. And I just didn't have the time. I ended up having to go, obviously you guys know, I go to work at night now. Though I haven't had too much time to research that particular topology, that particular lab. But there has to be a way to do it. There has to be a way to do it. And I'm just doing it wrong. So I'm going to delete that lab, though. We're going to start a new one because the problem is if I turn that back on, it's going to break again. Because once that thing started to break, it just kept on crashing. Every time, it just kept on crashing. Crash, 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 crash. So, okay. Let's gonna do this again, man. We're gonna do this again. And again, I'm gonna use 2 switches. Okay, I'm gonna use 2 switches. I'm gonna use 2 hubs. All right, and the only reason why I'm using these hubs is for the VLANs. It's the only reason why I'm using these hubs, guys. Okay. And 2 PCs. That's it. Super simple lab. It should be super simple. But again, everything with me, though, is never super simple. And yeah, I don't even need to create more channels on this. I was doing that yesterday, but I'm only gonna create one Ethernet channel, so I should be good. And the only reason why I'm doing it all over again, guys, because usually when I try to go back and I try to like wipe these nodes and restart them all over again, it never works out. They usually stay broken. And even if I try to add them back into the topology, they just keep breaking. So that's the only reason why we're starting from scratchy scratch all over again, guys. So just bear with me just for a couple minutes. This shouldn't take me too long to set back up. Again, super simple topology. You know what I'm saying? Super simple. All I'm going to do is I'm going to make one Ethernet channel. Okay? Going from the disto switch to the main. I'm going to turn that Ethernet channel into a routed port channel. Okay? All right? And then that interface now, it's not going to be acting as a it's not going to be, when frames come in there, it's not going to, it's going to right away use layer 3 logic. It won't use any layer 2 type of logic on it, okay? All right, so we'll fire these 2s up. You guys know it takes a couple minutes on that to fire up. We have chapter 18 to get through today. So we got to get through chapter 18, and that finishes up. That finally finishes up chapter, part 5. So holy guacamole! I can't believe it. We're almost out of part 5, guys. It only took us well, it only took me nearly 2 weeks to get out of part 5. And then we have a really, really good part coming up. So part 6 here is OSPF. I can't wait to get into OSPF, guys. I'm super pumped up about getting into some OSPF. OSPF is pretty neat. And then following that, that's the dreaded part I'm not looking forward to, but we got to get through it anyways, is IPv6. Um, and then, I mean, I guess what I can say is honestly, once we get past IPv6, guys, we're smooth sailing. You know, we're almost across the finish line, because after that we have wireless LAN, technology to cover, and then yeah, that actually ends the first book, and then we'll be finally over to the second book. Woo! Finally over to the second book. We're making some serious progress, guys. Serious progress. I wouldn't have made it this far without you guys. You know what I'm saying? Without doing the stream. None of that. I would have never have pushed myself. I would never have pushed myself to make it this far, guys. And that's kudos to all yous out there that's been out there supporting this, and you know, and watching, and just staying in tune, stuff like that. So I want to thank every single one of you guys. You guys are all awesome. So, all right. So we'll give that a couple minutes to set up. Again, I want to do a review though of the last couple of chapters. That's just what I feel is always the right thing to do. Just because it helps again put that knowledge into my mind there. So it's something that's very important to me that I need to continue to do, and I hope you guys, you know, are encouraged by it. That chapter. So let's get through. Yeah, let's review these 3 chapters real quick. Yeah, these 3 chapters real quick. Because remember, we were stumbling and finding ourselves confused a little bit on some questions. So, but we'll breeze right through these real quick. So, the exhibit shows the output of the show IP interface brief command on router R1. All interfaces listed in the exhibit should work under normal conditions and have worked in the past. Which of the following is most likely is the most likely condition that would cause the output in the show in the exhibit shown in the exhibit. So what do we got for actual things? So this is one of those. This is that long one. So the switchboard connected to 501 interface is in the shutdown. 501. So get 501. What is it saying? Has been shut down on the switch. No. Because if you remember, if it's not getting any electrical signal, because that was the explanation of this one. If it wasn't receiving any electrical signal from the switch, then it would be status down and protocol down too as well. So that's wrong. The router on the other end of 0/0/1/0 interface has been configured with PPP, but R1 still uses the default HDLC. So there's possible mismatch. And what is that? The 0/1. So we have the status is up, but the protocol is down. Okay. Serial link connected to /000 has been having issues inside the telco network with the telco not currently supplying clock signal. 000 down. So that's down. That's having other issues. That's having like layer 1 type issues, I'm gathering. R1's serial 001 does not have any problems other than it doesn't have an IP address assigned. 001 that's down, right? That's 001. Again, this is a tough question. 011 down. All right, let's go with the misconfiguration. Which command would you enter to add the IP address on the router? So that'd be IP, and then mask, okay? Because there's no subcommand for the subnet, there's no subcommand for mask, and this would be in progress. So let's keep moving. Of the Cisco iOS commands that are typically used to view IP interface IP address and information, which one shows only the address but not the mask information? So that'd be the show IP interface brief. Which type of router port is commonly used to connect an external modem so that an engineer can remotely access? So like auxiliary. Refer to the diagram and the exhibit based on the information displayed. What is the cause of the connection interface having the down protocol status? There we go. It wasn't showing me nothing at first. So this was where the on R1 the clock hasn't been there's a mismatch configuration with the clock. Okay. All right. So no configured clock rate. So no configured clock rate. Okay. All right, because that was a serial link. All right. There, guys. So you are troubleshooting connectivity. All right, connectivity issues with the router. You type in the command show IP interface brief. You notice that the status is administratively down and the protocol is down. What is the meaning of this information? The interface has a shutdown command configured on it. Refer to the diagram. Which cable types is used in the reference location? So remember, serial, okay, but the channel service units and the data service units. All right. On modern day modem routers, I'm saying these are normally built into them, but again, this would still be a serial cable going from router to channel service unit and data service unit. Okay. All right. Refer to the diagram. Which route statement on R1 would be configured to ensure that all normal traffic goes to the 30.30? So here. Here sorry. Let me get my Epic pen. So here, all right. And which would be the routed primary path? So this path right here. And all traffic going to server A would go in the high priority. So server A right there. Okay. IP route. No. IP route 30.30.30. All right. Going to the 220, so that looks good. And then IP route, nope. And then IP route, yes. Okay. All right. PC1 has just powered on and has not sent any frames into the network. PC1 has statically configured IP address and default gateway. Is configured as the router's 501 interface. PC1 sends the ping 172.16.0/33 and gets a reply. What dynamic ARP entry should appear in the ARP cache of the various devices in the network? So remember the host here. All right, the host here. Okay, host there because this is 172.16.0.33. All right, when they send their ARP messages through, okay. They're getting back the router's interface information, okay? But the router itself, though, would then send an ARP message out to that host, okay? And then the router itself, in the router's app cache, would have the layer 2 information from the address resolution protocol stored inside of its cache there, not the actual host, okay? The host would only know the layer 2 information of the interfaces on the routers in its own broadcast domain. Okay. All right. So it'd be 00001 in the router's ARP table. So the MAC address of the actual host. Okay. All right. Host B issues a ping command to ping host D IP. Host B issues a ping command to host D's IP address. The ping command succeeds. Which of the following statements is true regarding the ICMP echo request message sent by host B? All right, so we got a couple of hosty hosts. So host B, host B, and host D. All right, and we're going through a couple things. We got to go through a couple switches to get to this router, and then through a wide area network, back through another router, back to another local area network, down the hub into the other host. Okay, so we got to do some thinking about what we're doing. The frame holding the packet as it crossed the cable between R2 and switch 3 has the host B's as the source MAC address. No, it does not. Okay, it would have this interface as its source MAC address. Okay, the frame holding the packet as it crossed the cable between switch 2 and switch 1 has the destination MAC address of. Nope, it does not. The frame holding the packet as it crossed the cable between router 1 and the local channel service unit data service unit has the destination MAC address of router 2 serial MAC address. Nope. The frame holding the packet as it crossed the cable between switch 3 and hub 1 has the MAC address of router 2 as the source MAC address. Yes, it does. Okay, because when it gets re-encapsulated, and then de-encapsulated and re-encapsulated again, you got to remember that it's going to be tearing apart that Ethernet header and trailer. Well, in this case, it's going to be tearing apart that HDLC header and trailer, and then putting it back into an Ethernet header and trailer. Okay, and then forwarding that frame through switch 3 through the hub to the host D down there. The frame holding the packet as it crossed the cable between switch 1 and router 1 has the destination MAC address of the router 1, and yes, it does. So even though host B over here is pinging host D, that frame, okay, that frame that's holding that packet, okay, is going to have router 1's MAC address as the destination MAC. Okay, all right, inside of the frame. All right, not the packet, not the IP packet. Okay, all right. Further the exhibit in the diagram, which static route statement could you add to the central router to ensure that the default route always existed in the routing table regardless of the interface state? All right. So what do we got? So we want to get central route, and this is our internet service provider 192.168.1.1. So we would give it the all zeros, the almighty to the 192.168.1.1 permanent. Okay. Yeah, that looks good. All right, let's keep moving again. I'll refer to the exhibit. The exhibit in the figure. A branch office is going to use Ethernet WAN link as the primary WAN link with the serial point-to-point link as a backup. The designer uses OSPF over Ethernet WAN link. What command enables you to configure floating? Okay, remember, floating static route on the branch router to 200.200.200/24. Okay, now remember, we have a couple things to point out here. We have OSPF and floating route. Okay, OSPF has an administrative distance of 110. Okay, so we're looking for something over 110. So here we go. We have 2 right here. We can eliminate these 2 right off the bat. Okay, obviously we have 80 and 105. Those 2 would not work as a good static route while using OSPF. Okay. So what do we need to do? We need to look at this interface and not this interface. So we need to look at the serial interface on the backup. So the serial interface is 150.150.150.1. All right, so that's the one we need. 150, 150, 151, 1. All right, there we go. All right. All right. In the internetwork shown in the diagram, R1 is the central router, and R2 is the R2 is the typical remote office. The network manager dictates that remote routes should all use the default route to forward packets back to the central site, while the central site router should use a static route to forward packets to the remote office local area network subnet, as shown in the network, as soon as the network manager has correctly implemented the design, you connect to router 1 and not routers 2 using telnet and issue the show IP route command on each router. Which of the following answers list the output of that command? Okay. What do we got? So we got a subnet of 172.17.6.6.24. So what do we got? So this right here matches that subnet right there. Okay. So that would be a good static route for us. Okay. Via 172.16.1.2. So beautiful, right off that interface. All right, very good. And that's on router 1, so we're good on that one. And then we're looking for the branch. All right. And we want to just blast it out the almighty default route there out of our serial interface. All right, very good. All right. What's up, baby? Oh, I gotta send a hug out to me wifey. Send the hug out to me wife. All right. Which Cisco iOS command can be used on a router to view the different VLANs that have been configured on a router on a stick configuration? That is the show VLANs command. Okay, the show VLANs command. All right. What is the purpose of configuring multiple switch virtual interfaces on a layer 3 switch? All right, and that to support routing between subnets reside on the local area LAN, to convert, nope, to provide layer 2 connectivity, nope, to provide reachable IP access to remote access, nope. All right, to support routing between the subnets residing on local VLANs. Okay, good. All right, let's keep moving. When Cisco iOS command, which Cisco iOS command is used on a 2960 switch to change the switch forwarding ASIC setting to make space for the IPv4 route? So that'd be the SMD preferred LAN-based routing. Okay, LAN-based routing. Okay. All right. Which answer lists a configuration step on a Cisco access switch to support IP routing using only switch virtual interfaces? Okay, select the answers. The VLAN associated with the VLAN interface must be configured inactive. Each route physical interface must be configured with an IPv4 address. Each physical port the switch is enabled IP routing. Each VLAN interface must be configured with an IPv4 address. And that one. All right. Let's keep it moving. All right. Refer to the diagram. Which Cisco iOS command would be configured on router 1 on the gigabit 0-0.300 interface, so that it handles all non-MAC traffic for VLAN 300. Okay. So that'd be the native encapsulation VLAN 300 native. Okay, all non-MAC traffic. Okay. Whoa! I'm going too fast. All right. Why did I even say that? I knew it was that one too. All right, keep it moving. All right. Which two statements must you perform to enable a router on a stick? A router sub interface. Select two answers. Configure the sub interface with an with an IP address. Yep. And then yeah, okay. When you are configuring routed ports on a layer 3 switch, what do the physical ports act as? All right. When you are configuring routed ports on a layer 3 switch, so they're acting as layer 3 interfaces. Okay, not switch virtual interfaces anymore. Okay, they're acting as layer 3 interfaces. Okay. Refer to the diagram. In the exhibit, the engineer is checking the work of a coworker who is responsible for developing the router and configuration. On R1, which options are true of the potential configuration? Okay. We gotta select 2, so it's a funky one. So point 100 is VLAN 20, point 200 is VLAN 30, point 300 is VLAN 40. Point 200 is supposed to be VLAN 30. That's wrong. That one's wrong. So these two are wrong right here. Okay, that much. The interfaces handling VLAN 30 and VLAN 40 traffic have their assignments reversed. Yep. All right. And what else do we got? The VLAN assignments is wrong. The physical interfaces as command is valid. That's no. That's no. 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 And the physical interface has a command that is invalid. Yeah. Yeah, you don't need to give it the encapsulation .1Q on the physical interface, just on the sub. All right, there we go. All right, cool. We did pretty well. I just biffed it on that one. All right, cool. All right, so we got these up now. Let's do this real quick. See how fast I can get through this. All right. So we're not going to use any dynamic protocols to do this now, because I want to see if that's what was breaking this lab yesterday. So what we want to do, interface port channel. I'm going to say port channel 1. Okay. No switch port. All right. No switch port. IP address 10.0.0.1 0. Shut. Hold on. Sure. Make sure we're doing this all right again. I've done this a couple of times now. I have it pretty much locked in my memory bank. I just still like to make sure though. Just because how many times I broke it yesterday, guys. I need to ensure that I'm not only doing this configuration correct, but we're gonna have to figure out why I kept breaking this yesterday. All right, so we hit it with the no shut. We configured it with an IP address. Okay, now let's move into interface gigabit 0-0. Well, gotta hit it with the range gigabit 0-0. we're gonna give this the no switch port command. I'm gonna give this. We're also gonna give this the no IP address command. Okay. And then we're gonna say channel group. Oh, what's up, my muffin? Yeah, I know, man. I got 7 peeps up in there today. This is awesome, dude. I think this is like the most I've had in here, my muffin. How we doing today? Good to see you, man. All right, channel group 1. Now, remember, I am not going to give this a dynamic protocol today. We're going to statically configure this channel group. All right. So that should be good. All right. Now let's go over here to this one. What? You took your exam today, dude. That's awesome. You got a 906, dude. That's a crazy high score, man. Dude, congratulations. Dude, everybody in chat right now, give my boy, give my people's muffin some congratulations. Oh, you're gonna get a hug for that, my muffin. Were they horribly worded? That scares me. Dude, I am so proud of you, Muffin. I am so proud of you. That's awesome, dude. That pumps me up right now. That pumps me up, my Muffin. Hold on. That pumps me up right now. We got to do a little celebration for me, Muffin. My Muffin! My Muffin! He passed! He passed! Woo! 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 Did Bozen help a lot? Still offensive. It was worth the $90. Probably. That's awesome, though. You know what? I tell you what. If $90 was all it cost, and you were able to pass it, though, you know, I would just take that as a, you know what, you're gonna make so much, you know, your employment opportunities and everything else are just gonna be so much, you know, greater going forward. And just the experience alone, and just all of that you just probably went through, dude. It's, you know, spending that $90 was probably worth it. Definitely was probably spending that $90 was probably worth it. Tell you what, it's probably a lot. That's a lot less than what I've spent so far to try to get ready for this exam myself. I've been beating myself up with O'Reilly subscriptions, and everything else that I've been doing. That's awesome that you were able to do it off the OCG and the Boson basically. That's awesome. So I mean, yeah, that's one thing that freaks me out, because just going over the Pearson test stuff, the Pearson test stuff is horribly worded as well. So it makes me think just how bad that exam. It just makes me feel as though how bad the actual exam is going to be wordage wise. That's awesome, man. Dude, congratulations. You pumped me up right now. You better be throwing like a party or something like that for yourself. So what's the next step though? Oh, that's not too bad. Out of the 104 questions, like 4 were badly worded. That's not too bad then. I guess. That's not too bad. If only four were that badly worded, I should be able to deal with that. Come on, Joe. Use your mind. No snap, CCNP. Woo woo. Now we're getting into some. We're getting hot and heavy now. Is it really completely Juniper? I haven't even I haven't dabbled in anything Juniper yet. Um, I'm super interested to know, um, yeah, how that goes and stuff like that. Um, dude, I'd be super pumped um, if you once you start studying for your CCNP enterprise, dude. That's hardcore, man. But would would be would be good to have more knowledge about Juniper specifics. Yeah, I mean, I guess, yeah, especially if you're taking on a if your new job is going to be Juniper centric, you know what I'm saying? It'd probably be definitely worth spending the time to focus on that type of studies, you know. Um, dude, that's awesome, dude. That's awesome. That pumps me up right now. Super pumps me up. How long were you studying for, Muffin, though, for the CCNA? I know it wasn't that you were like super high speed, and it wasn't you haven't really been studying for that long, so that's super encouraging. Channel group 1. 8 months, but it wasn't like every day at all. Yeah, that's what I'm saying. Like you were super high speed. That's awesome, dude. You know what? That encourages me that hopefully with doing, yeah. All right, like 3 or 4 months. So that again, that I'm hoping though with everything that I've been trying to crush out that that once I get to the exam point, I should be I hope I can be I can be in good shape to be able to pass without too many issues. That's the hope, my muffin. Because I hate the job I'm working at right now, my muffin. And my wife can contest it. I'm stuck working a retail job again overnight, and I hate it. I want to strangle. I want to strangle my customers. All right, so let's do a do show Ethernet. Get out of this configuration mode though. Do show Ether channel some. We have our ether channel up. Let me check over here. To show ether channel. If I can spell show right. That's up. Now let's do a do show. Do show. So we have our port channels up. All right, so we're good there. Our port channels are up. Now, what I'm going over tonight, Muffin, is when I was going over routed layer 3 routed ports, I kept crashing. I kept crashing this virtual switch here every single time, because what I would do is I would create what I just did now. I would create the Ethernet channel port as a routed port like I just did here. And here I could show you I'll show you the show. Let's do the show. Yeah, let's do the show. Do show. Interface. The right information I want to see. Show channel status. Detail port. Good detail. It's not giving me the information I was looking for. Either way, what was going on is when I would create this as a routed port, I kept on, every time I would trunk it over on the main switch, because I was trying to trunk the port group to do VLAN, obviously like VLAN tagging and whatnot. And every time I would trunk it, I kept breaking I kept crashing the switch every single time, without fail too. It was pretty epic. I'm just looking for something. I want to see. Yeah, all right, show interface status. That's the command I was looking for. Do show interface status. All right, so there we go. Do show interface status. So this is what I was looking for right there. Okay, so this is identifying as our port group is good. So it's up, it's running. It's a routed port now. So we are in the clear. And then these right here, these are just showing that these are the two ports that are obviously in the actual combined port channel, Ethernet channel, whatever you want to call it, and that they're acting as routing ports. So we are good there. So that's up. All right. Now let's do this. VLAN 10, and then VLAN 20. So I made my two VLANs real quick. All right. Now I'm gonna go over to what are the two interfaces? One of the hubs. 2 and 3. Okay. So interface gigabit 0-2. All right, switch port access VLAN 10. Interface gigabit 0-3. Switch port access 20. Okay, exit. Let me just hit this with a do right. Now this is where I was going. This is where I'm probably going to break this again. So let's go interface port channel 1. Point 1. All right. Now this brings me to the sub interface on the port channel now. Okay. All right. All right. Now this is where I don't know if I'm doing things to this switch that it can't do. I might be doing things to this switch that it can't do. But I'm imposing, I guess, like routing type logic to it, or routing type interface, like configurations to how I'm treating this port now. Okay. And that's what I was trying to do. So, let's do encapsulation .1q. We're going to say 1. We're going to say native VLAN 1. Okay? All right. If the interface doesn't support baby giant frames, all right, that's fine. But that shouldn't be what my issue is. It shouldn't be crashing because of this. Shouldn't. Okay? All right. IP address 10.0.0, 10.1.125.25.0. Okay. Even though I don't need to. Interface port channel 1.10 now. All right. Encapsulation .1q. We're going to say VLAN 10. Okay. I'm going to say IP address 10.0.10.125.25.0. All right, interface port channel 1.20 now. Encapsulation .1q 20 IP address 10.0.20.125.25.5.0. All right, IP DHCP pool. Let's say 10. All right, network 10.0.10.0.25.5.0. Default 10.0.10.1. All right, IP DHCP pool net 20 network 10.0.20.0 255.255.0 default 10.0.20.1. All right, exit. Let's write this configuration real quick. Now, I should be good. I should be. Because this is how you would create this. Again, this is how you would, at least this is how I'm thinking. This is how I would build this configuration. All right. Normally, this is how I would build this configuration. Okay. We can do a do show run real quick to take a look. All right. Now I'm hoping though, because I didn't apply any dynamic protocols to the port channel, and I'm hoping that was the only reason why this was breaking yesterday. So we have our interfaces, our sub interfaces on our port channels now. Yep, they all look good. Yep, everything looks good. Everything looks solid. All right. We even got, we got our DHCP. So we have a DHCP server running and everything else. All right. Very, very good. All right. I'm comfortable with that. All right. Now, and this is where things get a little fuzzy. Do I trunk the port group? Or do I trunk the interfaces? That's what I was getting a little fuzzy on. And that's what was kind of, I don't know if that's what was breaking everything. If they're acting as let's do this. All right. Interface. Switch port, mode, trunk, and cap. Switch port, trunk, encapsulation, .1Q. Switch port, mode, trunk. All right. Did I break everything now? Yep, I broke it again. So that is not possible. At least how the way I'm doing it. I just crashed the switch again. So it wasn't that dynamic protocols. Yeah, it wasn't the dynamic protocols that did that. Man, that's a bummer. That's a bummer. Again, I don't know if it's that truly stinks. All right. Let's undo that. No. Switch port. Oh. Turn it back to an access port now. Yeah. So let's, if the interface doesn't support the baby giants frames, yeah, yeah. If anybody knows, I mean, Muffin, if you just saw what I just did, if anybody has any I guess like suggestions or advice maybe on why I keep exploding this switch, definitely give me a shout out. Because again, it tells you how to create the routed port channels in the book. All right. But I even, man. So I mean, what's funny, and this is what I'm trying to do. This is again, it could be the way I'm doing it because it should be possible. Because in the actual, I have the command guide too, And the command guide, if you ever read the CCNA portable, I also have the portable command guide. If you've ever read that, um, it's loaded with multiple varying, multiple variation of configurations. You know what I'm saying? It has different 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 configurations for different type of topologies and everything else. That's all it has in it. You know what I'm saying? But it's all command line based. Um, I love again. Some people actually hate on the book. I don't know why. I think it's a great book. I think it's awesome. What's his name? Scott Empson. Empison, if I'm pronouncing his name right. He wrote the book. I also purchased his other book, the CCNP, the CCIE Advanced Routing book too. I purchased that one too because that's another great one that's loaded with all different uh, command line based topology examples and whatnot. I think they're amazing. But this what I just did is in this. Um, so I mean, and they're implementing BTP and stuff like that, and they're also implementing LA. Is it LA? Yeah, they're implementing excuse me um port adjugate protocol as well. And I thought it was I was doing that yesterday, and I thought that's what was breaking it, but I guess it wasn't what was breaking it. So it came back up. That's good. Um, hmm. Do show. If I could spell. Yeah, see, I don't have a trunk. And I need a trunk because I need a trunk. Because if not, if I don't have a trunk, then oh. Yes, yeah, this is where I'm getting. Man, I need a trunk port. I mean, it's just no way around it. I need a trunk port. Let's break it again. At this point, I'm not really too worried about it. Let's move into interface, range, gigabit 0-0 to 1. All right, now let's give that the switch port, trunk, in cap, .1Q. All right, and then switch port, mode, trunk. All right, let's see if this breaks it again. It might. Are we in luck? Are you not going to break this time? Or did I lose my port channel? I think I lost my port channel, actually. Yeah, I lost my port channel. Pretty sure I did. Alright, so if I do show internet channel, port channel. Yeah, go down. Alright. Yeah. S is for suspended, so they're actually they're down. Oh. Man. Let's read it. Shades down. P1 is not compatible with PO1 and will be suspended. DTP is off. Shades down. Go to your book. Remember. Oh, I oh, I love you, baby. What it is this is something that let's take a look. Yeah, see, it's not it's not actually covered in either one of these books. At least not how to do it like the way I am trying to do it. Again, I might be trying to do something that's not possible. It might be. Might be what I'm trying to do. I might be trying to do something entirely not possible. You know? Even though I want to say it should be. But yeah, so I'm just getting stumped on that part. All right, let's move on. I digress. All right, this is gonna take me some more time to figure out what I'm doing, and so that's fine. All right, let's crush chapter 18 so we can move on to OSPF. All right, chapter 18: troubleshooting IPv4 routing. Configuring and verifying IPv4 addresses and subnetting. Configuring and verifying IPv4 address and IPv4. Configuring and verify IPv4 and IPv6 static routing. Default routes, network routes, host routes, floating routes. The first 3 chapters in this book took you from a starting point of understanding IP addressing and subnetting to details of implementing IP addressing, routing between connected subnets, and configuring static routes. All those steps included the idea of configuring a command and seeing a route show up in the IP routing table on that same route. In this chapter turns your attention to routing from end to end across the entire enterprise network. How do you troubleshoot an IPv4 network? How do you verify How do you verify correct operations, identify root causes, and fix those from various IP routing features. How do you do that in the presence of an IP addressing and subnet plan requiring you will apply all the subnetting math from part 4 of this book and the basic address and mask and static route configurations from the other chapters here in part 5. This chapter answers some of those questions. And particularly this chapter focuses on the 2 tools you use, how to use them. Ping and trace route. Both test the IPv4 data plane. This is the ability the ability of each networking device to route and forward IPv4 packets. This chapter devotes a major sections to each ping and troubleshoot. Trace route, I'm sorry to say. Ping and trace route. I keep on wanting to say troubleshoot. That's awful. What's wrong with me? The chapter then ends with a short discussion of 2 other routing tools that can also be useful for troubleshooting Telnet and SSH, Secure Shell. Okay, let's do do I know this already? No, this starts off a little differently. It doesn't have the actual do I know this already questions, huh? That's funny. I put the do I know this already in the tools to help you decide to approach it. However, this chapter does not have a do I know this already quiz because I think you should read it regardless of your prior knowledge. As with all chapters in the book, this chapter introduces new concepts, but it also acts as a tool to review and deepen our understanding of IP routing. I hope you enjoyed the perception of using ping and trace route in this chapter. So so ping and trace route, I use ping all the time. Ping, 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 pong. Ping's awesome. And trace route is awesome as well. So, how big is this chapter? It's not too bad. All right, let's get into it. Problem isolation using the ping command. Someone sends you an email or text or a phone message asking you to look into a user's network problem. You SSH to a router and issue a ping command that works. What does that result rule out? What does that result rule out as a possibility reason for the problem? What does it rule in as still being a possible root cause? Then you issue another ping to another address, and at this time the ping fails again. What does the failure of the ping command tell you? What part of the IPv4 routing may still be a problem, and what parts do you know are not a problem? The ping command gives us one of the most common networking troubleshooting tools. When the ping command succeeds, it confirms many individual parts of how IP routing works, ruling out some possible causes and current problems. When a ping command fails, it often helps us narrow down where the internetwork, the root cause of the problem may be happening, and further isolating the problem. This section begins with a brief explanation of how ping works, and it then moves into some suggestions of analysts of how to use ping command to isolate problems by removing some items from the considerations. Ping command basics. The ping command tests connectivity by sending packets to IP addresses, expecting the devices at the address to send packets back. The command sends the packets that means if you receive this packet and it is addressed to you, send a reply back. Each time the ping command sends one of the packets and receives the message sent back from the other host, the ping command knows a packet made it from the source to the destination and back. More formally, the ping command uses the Internet Control Message Protocol. The Internet Control Message Protocol, the ICMP message, the Internet Control Message Protocol. Specifically, the ICMP echo request and the echo reply message. The ICMP defines many other messages as well, but these two were made specifically for connectivity testing by command, like ping, as a protocol. ICMP does not rely on TCP or UDP, and it does not use any application layers protocol. It functions as part of layer 3 as a control protocol to assist IP by helping manage the IP network functions. All right. The figure shows the ICMP message with header. In the example, in this case, the user at host A opens a command prompt and issues the ping 172.16.2.101 command testing connectivity to host B. The command sends one echo request and waits. At step 1, host B receives the message and sends the echo reply at step 2. Okay, so that's the request and the reply. All right. The ping command is supported on many different devices and many in many common operating systems. The command has many options. The name of the IP address of the destination, how many times the command should send an echo request, how long the command should wait, the timeout for an echo reply, how big to make the packets, and many other options. And the example shows a sample from host A with the same command that matches the concept in the figure. Ping 172.16.2.101 command on host A. All right. So there's a little pingy. All right. Ping. All right. All right. Let me just drink some coffee. Everybody's doing good out there today. I got the night off of work.
Shh, don't tell anybody. It's me and the wife's anniversary coming up. I need ideas to make it a good anniversary for her. Don't tell her I said anything. She might be listening.
All right. Testing longer. Testing where did I leave off? Oh, the problem with using ping command from routers instead of from the host that has the problem. Where did I leave off though? All right. Actually, I skipped the whole entire chapter. Often the person handling the initial calls from the users about problems, often called a customer support rep or CSR, cannot issue ping commands from the user's device. In some cases, talking users through typing the right command and making the right clicks on their machines can be a problem, or users just might not be available. As an alternative, using different ping commands from different routers can help isolate the problem. The problem with using ping commands from routers instead of from that host has the problem is that no single router ping can exactly replicate a ping command done from the user's device. However, each different be right back, baby. Gotta call the kids. She's gotta call the kiddos. However, each different ping command can help isolate a problem further. The rest of the section of ping command discusses troubleshooting IPv4 routing by using various ping commands from the command line interface as a router. Testing longer routes from the near source of the problem. Most problems begin with some idea like host X cannot communicate with host Y. A great first troubleshooting step is to issue the ping command from X for host Y's IP address. However, assuming the engineer does not have access to X, the engineer can instead issue the ping from the router nearest to X, typically the router acting as host X's default gateway. For instance, in the figure, imagine that the user of host A had called IT support with a problem related to sending packets to host B at the 172.16.2.101 command on host A. Would be a great first troubleshooting step, but the customer service rep cannot access host A or get in touch with the user at host A. Cannot access host A or get in touch with the user at host A. So the customer service rep telnets to the router R1 and pings host B from there as shown. And there we go. Just showing you a little bit of the pingy. First, take a moment to review the output of the iOS ping command. By default, the Cisco iOS ping command sends 5 echo messages with the time of 2 seconds. If the command does not receive an echo reply within 2 seconds, the command considers the message to be a failure, and the command lists a period. If a successful reply is received within 2 seconds, the command displays an exclamation point. So in this first command, the first echo reply timed out, whereas the other 4 received a matching echo reply within 2 seconds. As a quick aside, the example shows a common and normal behavior for the ping command. The first ping command shows 1 failure to start, but then the rest messages work. This usually happens because some devices in end-to-end routes is missing the ARP table entry. So that goes back to, gotta remember, when, say, if we're in a topology where the ARP cache hasn't been populated in the router per se. Okay, when you send a ICMP echo message, all right, what happens though is that ARP message their ARP cache needs to be populated with layer 2 information. So those ARP messages start, blasting out, trying to find who's at what address. And when that happens, your ICMP, your pings will fail. Maybe your first, maybe your second ping may possibly fail due to that moment in time when those ARP messages are trying to find out information before your ICMP echo request can be answered back. So that's why you might see a drop of maybe your first or second ping initially. Okay, but once that ARP table is populated, usually by then your pings should be succeeding almost instantaneously, or populating, well, at least getting the replies back within before the timeout period there. So that's what that states right there. At least that's what that's covering right there. All right. Now think about troubleshooting and what a working ping command tells us about the current behavior in this internetwork. First, focus on the big picture for a moment. R1 can send an ICMP echo request to host B, 172.16.2.101. R1 sends the message from the outgoing interface IP address by default, 172.16.4.1. In this case, host B can send a ICMP echo reply message to router 1's 162.16.4.1. All right. So, all right. Boop, 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 boop. All right. Host B can send the message. Yep. Host sends the reply message, the ICMP echo. Yep. All right. Next, think about the IPv4 routing. The forwarding decision. Router 1 must have a route that matches host B's address. This route will either be a static or one learned with routing protocol. R2 also needs a route from host for host B's address. In this case, connected route to host B's subnet 172.16.2.0/24, as shown in the top arrow. All right. Just talking about routes. All right. The arrow lines on the bottom, of the figure show the route needed to forward the ICP echo reply message back to our 172.16.4.1's interface. First, host B must have a valid default router setting because 172.16.4.1 sits in a different subnet than host B. R2 must also have a route that matches the destination 172.16.4.1, in this case, likely to be a connected route. All right. The working ping command in the example also requires the data link and physical layer details to be working. The wide area network link must be connected, or must be working. There you go. The router's interface must be in the up, which typically indicates that the link can pass data on the local area network. Router 2's local area network interface must be in the up state. In addition, everything discussed about Ethernet LANs must be working because the ping confirmed that the packet went all the way from R1 to host B and back in particular. All right. The switch interfaces in use are connected in the up. Port security discussed in the CCNA 200-01 Volume 2 does not filter frames sent from R1 to host B. SDP has placed the right ports in the forwarding state. So it's pretty much stating that things are working. Okay, we have routes. Everything is in the up, stuff like that. So the ping 172.16.2.1 command also confirms that the IP address controllers, the ACL, did not filter the ICP message. One ACL contains a set of matching rules and actions. Some matched packets are filtered, discarded, while others continue on their path as normal. ACLs can examine packets as they enter and exit router interfaces. Shown in the figure shows the various locations of the router R1 and R2s, where the ACLs could have filtered, discarded the IC echo message. Note that the outbound ACL on router 1 would not filter the packet created on R1, so there is no rightward facing arrow. So it's just, yeah, so that's why there's no rightward facing arrow there. All right. Finally, the working ping 172.16.2.101 command on router 1 can also use the reasonable be used to reasonably predict that the ARP address resolution protocol worked and that the switch 2 learned the MAC addresses for its MAC address table. R2 and host B need to know each other's MAC addresses so that they can encapsulate the IP packet inside the Ethernet frame, which means most must have a matching ARP table. The switch learns the MAC addresses used by R2 and by host B when it sends the ARP messages, or when it sends the frames that hold the IP packets, showing the type of information in those. So here's just a look at some, this is just a high level look at packets and how things are being forwarded here. Pretty neat to look at. All right, let's continue on. All right, as shown, as you can see from the last few pages, a strategy of using a ping command from near the source of the problem can rule out of possibilities, root causes of any problems between the two hosts, assuming the ping command succeeds. However, the ping command does not actually act actually like the same ping command on the actual host. To overcome some of what is missing in the ping command from a nearby router, the next several examples show strategies for testing other parts of of the path between the two hosts that might have a current problem. So it's just stating that even though the actual router ping succeeded in its journey to ping the devices, we still might have some other underlining issues within this network topology here, and that's what we're going to be diving into. Using extended ping to test the reverse route. Pinging from the default router, as discussed in the past few pages, misses the opportunity to test IP routes more fully. In particularly, it does not test the reverse route back towards the original host. For instance, referring to the internetwork in the figure again, note that the reverse route does not do not point to the address of host A's subnet. When R1 processes the ping command, R1 has to pick a source IP address to use for the echo request, and routers choose the IP address on the outgoing interface. The echo request from R1 to host B flows with the source IP address of 172.16.4.1, which is routers R1's gigabit 0-0-0's IP address. The echo reply flows back to the same address, 172.16.4.1. A standard ping often does not test the reverse route that you need to test. In this case, the standard ping command on R1 does not test whether the route can be routed back to the subnet 172.16.1.0, instead testing the route for the subnet 172.16.4.0. A better ping test would test the route back to the host A subnet. An extended ping from R1 can cause the test to happen. Extended pings allow R1 command to use R1's local area network IP address from within the subnet 172.16.1.0. Then the echo reply message would flow to host A's subnet. The extended ping command does not allow users to type. Oh, don't freeze. I never freeze. What happened? There we go. I never freeze. All right. There we go. All right. I swear either my home internet or Twitch has just been acting goofy lately. I'm gonna blame Twitch just because I just, why not just blame somebody else. No, but Twitch was acting funny, so wicked funny earlier. It just wasn't allowing me to pull up anything earlier for some weird reason. It was weird. I don't know. That's neither here or there. Need water. Excuse me. All right. So, yeah. So the example shows the ping command on router 1 that matches the logic. The same command could have been issued from the command line as ping 172.16.2.101 source 172.16.101. All right. Cool. This particular extended ping command tests the same routes from the echo request going to the right, but it forces a better test of routes pointing back to the left for the ICP echo request reply. For the destination, R2 needs a route that matches the 172.16.1.1, which is literally to be a route for the subnet 172.16.1.0, the same subnet in which host A resides. All right. From a troubleshooting perspective, using both standard and extended ping commands can be useful However, neither can can exactly mimic a ping command created on the host itself, because the routers cannot send packets with the host IP address. For instance, the extended ping uses the source IP address 172.16.1.1, which is not host A's IP address. As a result, neither the standard or the extended ping in these two examples so far in this chapter can test for some kind of problems, such as the following: IP ACLs discard packets based on host A's IP address, but allow the packets that match the router. So it's pretty much saying, there could be some kind of access control list denying host A from being able to send messages out R1's exterior interface. So that could be there. You know what I'm saying? You won't be able to, by pinging out of R1, you wouldn't be able to see that. The local area switch port security that filters host A's frames. So again, there could be some port security doing this too on the switch. IP routes on the router that happen to match host A's 172.16.1.5 address with a different route that matches the so that's saying there might be some kind of misconfiguration of a route, maybe. Yeah, and same thing right there, problems with host A's default route settings. So there could be some routing, there could be some access control lists, there could be some port security issues, or there could be some actual configuration issues on actual host A. Note, IP access control list and LAN local area network switch port securities are covered in the CCNA official 200 volume 2. For now, know that that IP access control list can filter packets on routers, focusing on the layer 3 and 4 header. Port security can be enabled on layer 2 switches to filter based on source MAC addresses. All right. Testing local area network neighbors with the standard ping. Testing using a ping of another device on the local area network can quickly confirm whether the local area network can pass packets and frames. Specifically, a working ping rules out any possibility, any possible root causes of a problem. For instance, the figure shows the ICP echo messages that occur if R1 issues the command ping 172.16.1.151, pinging host A, which sits in the same VLAN of R1's. Okay. If the ping works, it confirms the following. Which rules out some potential issues. The host with the address 172.16.1.151 replied, the local area network can pass unicast frames from R1 to the host, okay, vice versa. We can reasonably assume that the switches learned the MAC addresses of the router and the host. Yep, host A and R1 complete their ARP process and list each other in the respective ARP cache, okay? The failure of the ping, even with the two devices in the same subnetwork, point into a variety of problems, like those mentioned in the list. For instance, if the ping 172.16.1.151 on router 1 fails, the result points to a list of potential root causes. All right, so we have some IP addressing problems, some DHCP problems, VLAN trunking problems. All right, so kind of like what I was just running into earlier with me exploding my my switches, and some local area network problems. All right, so whether the ping works or fails, simply pinging a local network host from a router can help further isolate the problem. All right. Testing LAN, neighbor, and extended pings. A standard ping of a local area network from a router does not test the host default routing settings. However, the extended ping can help the host default routing settings. Both tests can be useful, especially for problem isolation, because if a standard ping of a local LAN has worked, but the extended ping of the same local area network fails, the problems likely relate to somehow the host default routing settings. Okay, so it's just stating that there could be you could have some issues with some of the actual settings on the actual device. Or that, I mean, this could be related back to DHCP. Maybe you don't have your DHCP configured correctly, and it's not pointing things in the right direction. Could be, you know, if a standard ping of a local area network hosts, yeah, okay, so we just read that. First to understand why the standard and extended pings results have different effects, consider the first standard ping. Yep. Y sent back echo. Comparison. We're gonna start breezing some of this, guys, just because I feel like it keeps on going over the same thing over and over again. Even though it is kind of not, but it is kind of at the same time. I just feel like I'm reading the same thing over and over again. All right, testing wide area network. 2 standard pings. All right. Using ping with names and with IP addresses, DNS. I mean, you guys have seen me do this before, but the biggest thing though is you need to make sure you have a domain name server up and running, or you're pointing it to an actual accurate domain name server somewhere out on the internet. You can use, hopefully your at home router is acting as a DNS server. Usually it is. Most cable service providers, home routers, have a domain name, have a DNS server running in them, or you can always point it towards Google's if you really need to. Sometimes that takes a little bit longer to get some name resolution back on that. But you can always point it to 8.8.8.8 out in the big world internet. You can always point it towards that too as well. I've done that before. It takes a little. Sometimes it slows things down a little bit because you gotta imagine it has to go all the way out to who know. I think it's going out. I think that server. I mean, that server is probably a virtual server in the Google's cloud somewhere. So who knows where it could be at any one moment. You know what I'm saying? But it's probably out, for instance, it's out on the west. It's probably usually always out on the west coast somewhere. So depending on where you're at in the country or where you're at in the world, pointing it towards there, again, it might take some time for those messages to come back. So it might just slow things down a little bit. But when you're pinging things for DNS connectivity, it's good. It's good to do that too. That way, like for instance, like if I blasted up a topology right now and I didn't have DNS properly set up, yeah, I could reach things via using IP addresses, but I could not just jump on a web browser and put a name in and then expect to get anything back. It would not work that way. So pinging address names to find out if you have proper domain names system up and running is super important too. Yeah, making sure you're resolving that. So, when troubleshooting testing from the host by pinging user's host name can be very helpful. The command, of course, tests the host of the DNS client settings. For instance, a classic comparison into the first ping the destination using destination host using the host name, which requires a DNS request. That repeats the same test, but using the host IP address instead of its host name, which does not require the DNS. If the ping of the host name fails, the problem usually has something to do with DNS. So, yeah. All right. Now let's talk about traceroute. All right. Like ping, the traceroute command helps network engineers isolate problems. Here's a comparison of the two. Both send messages in the network to test connectivity. Both rely on other devices to send back replies. Both have wide support on many different operating systems, and both can use hostname or IP address to identify the destination. On routers, both have the standard and extended versions, allowing for better testing of reverse routes. Okay. The biggest difference related to more detailed results in the output of traceroute command and the extra time and effort it takes traceroute to build the output. The second major section explains how traceroute works, plus it provides some suggestions on how to use this more detailed information than a more quickly to quickly isolate IP routing problems. You know what? All right. I'm going to kill this lab. Ready? Bye-bye, labo. All right. I'm going to jump out of that lab. Do I have... Hello? Hello? What do I got? What do I got, man? Let's get a simple labs up real quick, guys. No, I don't want to use the CSR. My other boy was in here the other day. We were struggling to get that thing to work. I don't think we ever got it to work, honestly. That's not crazy, not fancy. Grab a couple of routers. We won't do nothing spectacular here. Nothing spectacular. That way we can just breeze through this. We're just gonna do. I just need a couple of routers so we can do traceroute and see some. Oh, what's up? Got mine on January 14th. Oh, you got your Mara Doxabat. You got are you planning for your CCNA test on the 14th? Is that what you're saying, my friend? No doubt. Oh snap. How you feeling, my friend? Are you ready? Totally. That's awesome, dude. That pumps me up. I'm shooting for near the end of February for mine. I am nearly there. I'm about to finish the first part of the official cert guide now. So I still have a whole other book to go through. But dude, that pumps me up, man. That pumps me up. Yeah, man. Tell me how your study's been going. Like, what have you been using for your study? Have you been using the official cert guide? Have you been using some David Bumble videos? Boson? What have you been using? All of those, right? That's what I do too. I can't say I've used Boson though. I haven't had any. I've actually never used anything Boson. Um, I've heard great things about it. My boy Muffin was in the chat earlier. He just actually passed his. Um, is it great? Yeah, I know a lot of people use Boson, man. So there's gotta be something good about it. Um, there's gotta be definitely it's definitely gotta be worth it. That makes me think. Um, I've always, it's made me think if maybe it'd be worth for me to invest into actually picking it up. You know what I'm saying? Um, because at least from what I've seen, it walks you like through each lab. At least that's from what I saw from it. Um, which again, that's super helpful. If something can walk you through a lab, like today, I don't know how long you've been up in the stream for. Today, I kept blowing up. I kept crashing a layer 3 switch, um, because create a, I was trying to create a trunk port over over a um, over an Ethernet port channel. Um, yeah, a routed port channel. How's that? And I kept every time I would configure the other switch to have a trunk port, it kept crashing the other switch. It would just crash it like that, which stinks because what I was trying to lab is how to use a layer 3 switch as like you would use a router to route between. I mean, I could have done it the other way with using the layer 3 switch, using the switch virtual interfaces, but I wanted to do it using with configuring the routed ports, the Ethernet channel ports, to do it instead of using the switch virtual interfaces. So, um, but that's, but yeah, I mean, that would have been super helpful to actually have something walk me through the step by step, so I wouldn't continue to crash my switches over here, because I still haven't figured it out yet. The thing is, I don't even know if what I was trying to do was even possible, honestly. Um, I don't think it, I don't know. I don't know. But dude, that's awesome, man. I'm pumped up. I'm pumped up. Boy, you pump me up right now. So what subjects did you find? What subjects did you find that were like more difficult for you to um wrap your head around, or were you just like super like already super knowledgeable into this stuff? Do you have an IT? Do you already work in IT? Do you have an IT background or anything? I cracked my window because it was getting hot. Now it's getting cold in here. Like take for instance, like myself, like I don't have a IT background, or because I've never actually worked in IT. I'm honestly pretty new to all this stuff. So it's taken me a little bit longer to like to get like the core fundamental concepts like wrapped around in my tiny little brain I got in my head. So it's taken me. I started back in August with my studies, and it's taken me thus far to start really like getting these concepts down. And I tell you, like this, and I keep telling everybody, doing this stream has really forced me to really, well, it's just helped me wrap my head around these concepts better. You know what I'm saying? By getting input from people joining the stream and whatnot, and everything else. So. Zip bus. Oh, really? Dude, you got a lot of certifications. But I have Sec Plus, Junos. You know what's funny? It's I guess that's why you then in that statement what you just said, that's why I think the CCNA is not an entry level cert. And um that's why I think it's so important because of that statement and because it reigns so true because again and I've said this a couple times actually in the stream is the CCNA cert. It covers a broad scope, a super broad scope, but it covers a lot of what is fundamental about networking and what about all these parts of these technology. It touches on a lot of parts of these technologies that are super critical, even in today's world. Where everything is starting to go virtualizing and everything else, but fundamentally, yeah, at the end of at the the base layer, these fundamental concepts, these fundamental areas that the CCNA cert covers is still pertinent. It's still super important to have this knowledge. Even, if you're going into Linux, Linux administrative, having these fundamental networking understandings, it'd be a plus, even if you're a Linux admin, at least in my opinion. You could tell me I'm wrong, but at least in my opinion, like I said, having the CCNA level knowledge, I just feel as though it's going to no, go back down. It's going to yeah, exactly. It's going to help me continue to further where I want to take my career and stuff like that. So that pumps me up, man. That pumps me up hardcore. All right. Let me blast out. Let me blast in some of these configurations real quick. I just want to set up a quick and dirty lab real quick. That we can do some testing on. I just want to go over like trace routing and stuff like that. That's it. All right. That's good. That's good. All right. Ooh, where did I set it? I forgot. I always forget. Okay. All right. So address. Let's give everything. Let's go super simple with everything. 10 dot 10 dot 10 dot 0 dot 1 dot 1 5 5 5 dot 0. If I could spell, no shotgun, interface, gigabit, 1, the address, 10 dot 10 dot 0 dot 10 dot 1, 5 5 5 0, shot, IP, DHCP, pool. Network 10.0.10.0 to 5.5.0 default 1 exit interface loop back IP address 1. Router. Yeah. 1. 0. 0 dot 1. Oh snap! Woohoo! Oh, good looks on the follow! You my man! Thank you very much. Mara Doxbacks. Dude, you the man. Oh, girl, you the man. Or girl, you the woman. You're awesome either way. Thank you very much for that follow. Oh, you're gonna get a hug for that one. There's a virtual hug coming right for you. Good looks. Thank you, my man. Let me see. You just made me 47, 45 followers. So now I'm only 5 more followers away from finally achieving hopefully to become a affiliate here on Twitch. All right, area 0. All right. Exit. Router 1 done. Now let's go to router 2. All right. What are our interfaces? Man, I keep forgetting. Site 1. Don't break. Interface. Incubate 0-1. And what was that? Yes. 10.0.1.2. Yeah, that's good. Interface gigabit 0-1. Address 10.0.2.1. 0. Sure. Alright, interface, loop back. 1. Yeah, it's 1.1.1.2. 5, 2, 5, 5, 5. It. Yeah, it. Yeah, so right now what we're going over, I'm gonna call you Docsback. So we're going over chapter 18 in the official cert guide right now. And what I'm creating, I'm just trying to blasting a quick topology. So that way we can go over the trace route command. So what we'll do is once we get this going, we'll get on these here. And we'll kind of, what we'll do is we'll do some, we'll repeat some of what the book is talking about. Obviously, I mean, I could have done the same IP addressing scheme these things did, but my foresight wasn't that far yet. A little bit too fast for my own good sometimes. So we're creating just a simple topology, real skinny and simple. So that way we can take a look at what the trace route commands and all that look like physically. All right. So that's all I'm doing right now. I should be done real quick. Router OSPF 1. Network 10.0.0.0.1 area 0. Not area O. Crazy guy. Exit. Why didn't I make it adjacency yet? this one now. Yeah. D. All right. Interface. 0 to 0. So interface gigabit 0/0. IP address 10.1.2.2.5.0. Got right. Interface gigabit 0-1. The address 10.20.1.2.5.0. Got right. DHCP pool 2 network 10.0.20 0.2.5.5.0 default 1 right 1 yes 3 it yeah 1 ah 0.0.0 0. What's going on? I'm gonna take a look. Something's not working. Do show again. OSPF is not working. Come on. Gotta look at this. Gotta look at the show. Understand why OSPF is not working on so then we do something wrong. Huh, that would explain it. I guess I never set the IP address on. Did I really not do that? I thought I did. Oh, I'm goofy. Oh, I'm goofy goofies. Oh, that's funny. That's funny, Ducky. Huh. All right, I see part of my problem. Huh. That's one problem I had. Huh. There we go. Oh, so, what I get for going too fast, I guess. It's good now, right? What did I do? Oh, jeez, man. I got these all mixed up. Ha ha ha. Oh boy. Oh, that's funny. Man, Joe's a funny ducky today. Think of it. Zero dash 0-1. All right. IP address. Um, oh boy. Actually, let's do this. Interface gigabit 0-0. Let's try this again. All right. Say no. Interface gigabit 0-1. No. IP address 10.0.2.1. Okay. Now we're gonna go to that one. Yep. And then we're gonna say IP address. This time, I got it this time, boys and girls. I was like, what the heck did I do wrong? There we go. Interface gigabit. 0-0. There we go. We got some OSPF adjacencies now. I'm like, what did I do? Again, I'm going too fast. 10.0.2.1. 0. All right. Now we should be good. There we go. We got our adjacencies now. Woo! That was a Joe Biff. It's gonna be a thing, a Joe Biff. Get our adjacencies. Very good. All right. Let's fire these PCs on now. Oh, the router ID. No, did you see what I did? I had, so site 2, I flip-flopped my addressing. I had this addressing that was supposed to be for this subnet going this way instead of it going this way like it should have been. Because I'll write it on the board for you. So this let me erase that. So that's smaller. So this interface is 10.0.0.1.1, and I put on this interface because I was going too fast 10.0.2.1. And then on this interface going over here, I put 10.0.1.2. Totally biff caked it. Yeah. I guess I was going too fast, and I confused where my interfaces were. I do that sometimes. You should always have the interface names and subnets showing in the map, right? Showing in the map. Should always have the interface names showing in the map. Oh, so this is Cisco Modeling Lab. I don't know. Have you ever used Cisco Modeling Lab? In Cisco Modeling Lab, you don't have that option in Cisco Modeling Lab like you would on like GNS3. You have that option. Cisco Packet Tracer, you have that option. Yeah, just in PT Packet Tracer. Yeah. Yeah. So this is an emulator. Just like GNS. So this is very similar to GNS3. Honestly, I prefer using this than GNS3. My whole opinion with GNS3 is you have to actually purchase Cisco Modeling Lab to correctly use GNS3. So my whole thing is why would you want to use GNS3 anyways if you already have to purchase Cisco Modeling Lab to use GNS3? Because that's the only way you can get the yeah, all you need is Packet Tracer. Yeah. But what I'm doing next, so I got my whole thing is I got a whole server. Let me just log into my server real quick. What's up, man? Huh? Just a little bit, all right? So let me just log into my server real quick, and then I'll show you what I'm talking about. So this is so I got an ESXi server that I do all my virtualization on, and the reason why I started with Cisco Modeling Lab is because of what I'm going to be gutting into next, which I'm going to be from CCNA. I'm going straight from that to DevNet. So here, this is where I host all of my multiple virtual machines. and then I can create virtual switches on this server right here. This right here is a virtual switch I just created. I think it was a couple weeks ago, and what I'm using is this right here, this NX router. This is a PFSense, PFSense image. If you know, if you've ever heard of, you've probably heard of PFSense. PFSense is an Ubuntu-based. PFSense is an Ubuntu-based Linux image that acts as a virtual router. It's got a web GUI and everything. So what I have it doing, let me get back to that. Yeah. So what I have it doing is I have it. You can use it as a firewall too. But what I really needed it to do was I needed to break off other Linux servers because I have other Linux servers here. So I can create DHCP servers, DNS services outside of my own actual my own network. So I'm using this NX router or this PFSense router to perform network address translation. That way I can still reach out to the internet without being on my own, without being bridged, without actually being bridged to my network. All right, I'm natting off of my actual network. I'm breaking off of that. But what I was attempting to do with GNS3, because I got GNS3 here too, and this is where I'm running CML right now. What I was attempting to do is because I do a lot of I've been labbing Ansible and stuff like that. What I was trying to create is because there's companies that use Cisco Modeling Lab for production-based stuff, and because you can bridge out Cisco Modeling Lab to your actual networks or NAT it out. You know what I'm saying? I have labs in here that I've done all kinds of crazy things with. And what I was trying to do I was trying to use Cisco Modeling Lab as an actual virtual router to do some other type of labbing type scenarios and stuff like that. I had ran into problems with creating new port. I don't know how to, I guess, describe it. I was struggling to configure the bridges correctly. Like, I can make a bridge and all that inside of Cisco Modeling Lab and connect that to EXXI, and I got connectivity. I just couldn't get information to go back and forth successfully. How's that? Without running into too many issues. So that's more to come with as I get deeper into my EXXI knowledge, because eventually what I want, as I'm chasing because the DevNet cert will follow the CCNA cert. I'm almost going to get those a couple weeks apart from one another, just because how closely they're related. But my other goal for knowledge and for certification purposes is going to be chasing after the VMware architect certification as well, which is an expensive certification. That's about a $3,000 friggin' cert, because you got to go in front of a board, because you got to create an entire infrastructure inside of you got to create a whole entire infrastructure inside of EXXI and stuff like that. Yeah. Oh, thank you, man. I appreciate that. Thank you very much. But yeah, that's at least where I'm going, and that's why I'm hoping with all this stuff that I've been trying to dive into, that I will be prepared. Make sure we got some IP addresses here. We're good. I'm hoping I'll be prepared for the CCNA certification when I get around to taking it. All right, so we're good. We got IP addresses. All right, let's make sure Let's make sure we can ping the other PC. Yeah. All right, so we're good. So we can ping. So PC2 can ping PC1, and that's going through. So that's a similar scenario of how they have it set up here. All right, where we're crossing across multiple routers, multiple interfaces, and stuff like that. So let's do this. Let's do a trace route. Let's do a trace route on 10.0.10.2. All right, let's do a trace route and see what that looks like. Cool. So the trace route, as as you're seeing, it's going hop by hop by hop by hop. That's what a trace route is depicting here. And what I'll do, so we can have some context sensitive help here, because sometimes context sensitive help helps as we're going along here. All right. All right. So let's write down some addressing. All right. I want this color. This color stands out better. So on that interface, what do we got? What do we got? What do we got? We got 10.0.20.1. And then on this interface, we got 10.0.2.2. A little bit. All right, very good. Let's go over here. Show IP interface. My spelling is atrocious. What we got? We got 10.0.2.1, and then 10.0.2. One. So here we go. So there's some context sensitive help. Oh wait, let me and then the PC here is 10.0.10.2, and this one is 10.0.20.2. All right. So there's some of our context sensitive help. So we can have some visual, so you guys can see visually of where everything is kind of sitting at. Just like you were kind of stating, always having the interfaces and the IP addresses shown on the map and stuff like that. So there we go right there. I use EpicPen, by the way, if any of you guys are interested. That's what you guys are seeing right here. This is EpicPen. I love me some EpicPen. All right. So and then that's so again to what we're looking at. So the first hop, so from 10.0.20.2, so we trace route that, okay? So we want to get to this address, which obviously is this PC right here, okay? So the first hop, we're going to be going to 10.0.20.1, all right? So that's our first hop. Our next hop, okay, is boom, to 10.0.2.1, okay? Then the next hop from there is 10.0.1.1, all right, to the final ending address at 10.0.10.2. All right, so that's the trace. That's the workings of the trace route. Okay, now what I can do, these real quick, go over to this PC. All right, and you guys, if you guys are curious, you can verify that that's the actual address right there, guys. Okay, 10.0.10.2. Okay, all right. And if anybody's curious, these images that these PCs are using, these are Alpine Linux. Alpine Linux. Okay, you can download Alpine Linux images for yourself and boot those up and VirtualBox and VMware and whatnot. I've run into issues booting up IP Linux. Oh well, Alpine Linux images, but I have issues with everything. All right, so let's do a trace route to 10.20.2. All right, let's take a look at it going back now. Let's take a look at it going this way now. Okay, and what we're going to see some different addresses. Okay, because remember we're going through different base interfaces now. Okay. All right. So what do we got? So we got 10.1, 10.0.0.1. So we got this interface. Okay. Next hop, 10.0.1.2. This interface. 10.0.2.2. This interface. All right. And then the final address there. Okay, which is this PC 10.0.20.2. All right. All right. Now, if we can tell, we're floating on these interfaces, obviously, because these are the interfaces that are facing this PC right here. All right. And you take a look. So you can see the kind of the differences, okay, with how the information, at least on how this command, on how we're utilizing the traceroute command on this part. Okay. Now, let's get back to the chapter review real quick so we can kind of touch on what we're actually talking about here. All right. So thank you for bearing with me as I created that topology. We're going to get back to that topology as we continue there. All right. So traceroute basics. Imagine some network engineer or customer service representative starts to troubleshoot some problem. The engineer pings from the user's host. The pings from the nearby router. After a few commands, convince herself that the host can indeed send and receive IP packets. The problem may not be solved yet, all right? But the problem does not appear to be a network problem, okay? Now imagine the next problem comes along, and this time the ping command fails. It appears that some problem does exist in the IP network. Where is the problem? Where should the engineer look more closely? Although the ping command can prove helpful in isolating the source of the problem, the traceroute command may be a better option. The traceroute command systematically helps pinpoint routing problems by showing how far a packet goes through an IP network before being discarded. All right. The traceroute command identifies the router in the path from the source host to destination host. Specifically, it lists the next hop IP address of each router that would be in each of the individual routes. For instance, the traceroute 172.16.2.101 command on host A in the figure would identify the IP address of R1, and the other on R2, and then host B as it's shown in the figure, which follows the list examples of the command. All right, so just like what we just were looking at here, okay, with the traceroute command. So we're looking for the trace route. To trace route, we want to get towards that IP address 172.16.2.101. All right. So trace route to 172.16.2.101. All right, we're going for the next. Our first hop from there. Our first hop from where we're at host A is the 172.16.101. The next hop 172.16.4.2. Okay, and then our final hop, our final destination, right there at 172.16.2.101. All right. The traceroute command gathers information by generating packets that trigger error messages from routers. These messages identify the routers, letting the traceroute command list the router's IP address in the output of the command. That error message is the ICMP time to live exceeded TTL. Time to live TTL. exceeded. Okay, time to live, TTL. All right, can't say it enough. All right, originally meant to notify host when a packet had been looping around a network. Ignoring trace route for a moment and instead focusing on IP routing. IPv4 routers default routing loops in part by discarding looping IP packets. To do so, the IPv4 header holds a field called the time to live, TTL. Again, TTL, time to live. Okay. The original host that creates the packet set the initial time to live value. Then each router then forwards the packet discernments the time to live value by 1. All right, when a router disseminates, my speech is amazing. The time to live to 0. The router perceives the packet is looping. The router discards the packet. The router also notifies the host that sent the discarded packet by sending the ICMP time to live exceeded message. All right, now back to traceroute. Traceroute sends a message with low time to live value to make the router send back a time to live exceeded message. Specifically, a traceroute command begins by sending several packets, usually 3, each with the header time to live field equal to 1. When the packet arrives at the next router hosts A's default router R1 in the example. The router disseminates the time to live to 0 and discards the packet. The router then sends host A the time to live exceeded message, which identifies the router IP address to the traceroute command. Ooh, good stuff. The traceroute command sends several time to live packets time to live equal 1 packets, checking them to see whether the time to live exceeded message flow from the same router based on the source IP address, the time to live exceeded message. Assuming that the message can come from the same router, the traceroute command lists the IP address as the next line of the output of the command. Define all the routers in the path, and finally confirm that the packet flow all the way to the destination. The traceroute command sends a small set of packets, the time to live equal 1, then a small set of time to live equal 2, then 3, 4, and so on and so forth. I believe the default is 30. I want to say it's 30. If something's more than, yeah, it'll keep going, but I believe the default for a traceroute is 30. Did it say that already? Did I skip too much? Destination shows the packet time to live. Also, actually forwarded the packet while the other router R2 happens to disseminate it, causing the yep. The figure shows these 4 steps. The traceroute command. All right, let's scroll up a little bit. The traceroute command sends a packet from the second set with the TDL equals 2. Router 1 processes the packet and disseminates the TDL to 1. Forwards the packet. Router 2 processes the packet and disseminates the TDL to 0. Router 2 discards the packet. Router 2 notifies the sending host of the discarding packets by sending the TDL exceeded ICP message. The source IP address of that message is 172.16.4.2. Very cool. All right. Finally, the source IP address. Finally, the choice of source IP address to use on the time exceeded message returns by the router has a big impact on the output of the traceroute command. Most routers use a simple logic that also makes commands output like traceroute more consistent and meaningful. That logic chooses the time to live exceeded message source IP address based on the source interface of the original message that was discarded due to the TDL. In the example in the figure, the original message at step 2 arrives at router 2 gigabit 0-0/1 interface sold at step 3. Router 2 uses gigabit 0-0-1's IP address as the source IP address of the time to live exceeded message and as the interface out which the sending message. All right. And that's why that logic right there tells us that's why we're getting the interfaces that are facing the host IP addresses. Okay. The standard and extended option of traceroute command gives you many of the same options as ping. For instance, the list of the standard traceroute command on our one, like the standard ping command. A standard ping command chooses an IP address based on the outgoing interface for the packet sent by the command. So in this example, the packet sent by R1 can come from a source IP address 172.16.4.1 off of gigabit 0-0/0's IP address. The extended traceroute command shown in the example follows the same basic structure as the extended ping. The users can type the parameters of the command line, but it is much easier just to type traceroute, press enter, and let the iOS prompt for all the parameters, including the source IP address of the packets. All right. Very, very cool. All right. Both ping and tracenet command exist on most operating systems, including Cisco iOS. However, some operating systems use slightly different syntax for traceroute. For example, most Windows operating systems use tracecert. So there we go. So tracecert and path ping. So you might see those possibly on Windows. Okay. And now traceroute. Linux and OS X support traceroute command. So just like we were using over in Cisco Modeling Lab, these are Linux-based operating systems. So they have both the ping. All right. Which PC am I on? They both have the ping and the traceroute command. Okay. All right. So because the Linux-based operating system supports it, I don't have to defer to a different command line command to make this work. Okay. Very good. Very good. All right. Telnet and SSH. The ping and traceroute command do give networkers two great tools to begin isolating the cause of an IP address IP routing problem. However, these two commands tell us nothing about the operation state inside of the various network devices. Okay. Once you begin to get an idea of the kind of problems and possible locations of the problems using ping and traceroute, the next step is to look at the status and status of the various routers, switches, features. One way to do this is to use Telnet SSH to log into the devices. Common reason to use iOS Telnet or SSH client. I don't suggest anybody out there using Telnet unless you like hackers hacking into your stuff. So, everybody out there should by now be using SSH, SFTP, the more secured options for logging into your devices. All right. All right. Normally, a network engineer would log into the remote device using Telnet or SSH client on a PC, tablet, whatever, or on any other user devices. In fact, often the same software packages does both Telnet and SSH. However, in some cases, you may want to take advantage of the Telnet SSH client built into the iOS on the switches, on the routers and switches to Telnet SSH from one Cisco device to the next. Okay. To understand why, consider the example. The figure shows arrowed lines to three separate IP addresses on the three separate Cisco routers. PC1 has attempted to Telnet to each address from from a different tab in the PC ones, telnet SSH client. However, R2 happens to have an error in its routing protocol configuration, so R1, R2, and R3 fail to learn any routes from each other. As a result, PC1's telnet attempt to both 10.1.1, 10.1.2.2, and 10.1.3.3 fail. So what this saying is because R1 is actually having routing issues, the network admin or whatever sitting on PC1 over here in the actual figure, he can't actually log into any other, he can't telnet over to any other routers because exactly, we're having routing issues. So in some cases like this, telnet SSH login from the network engineer's devices can fail. While you could still find a way to log in using telnet SSH commands, to use telnet SSH client on a router or switch with this particular scenario, all the individual data links work. The problem is with the routing protocol exchange. Routes PC1 can ping R1's 10.1.1.1 IP address. R1 can ping R2's 10.1.2.2.2 address, and R2 can ping router's 10.1.3.3 address. Because each link works and each router can send and receive packets with its neighbor on the shared link, you can telnet SSH to each device. So that's pretty much doing like a device hopping, where you log into one device, you log into the other device, you log into the other device from those devices. So you're just doing some hopping around, and just don't forget where you're at. All right. So showing the idea on the left, PC begins with either telnet SSH console connection into R1, and then shown on the left, then it uses telnet command from R1 to telnet to router 2. Once logged in to R2, then you can issue the command on R2. Then from R2, the user can telnet. So it's just hopping between devices from within each device, if you can understand what I'm saying by that. And that's what this figure is showing. Instead of trying to get to all devices from one device, all right, because there's issues within the routing table on R1, that's not possible because R1 doesn't know how to route to, where did my mouse go? Doesn't know how to route to the other routers, but the connected local interfaces can communicate. So the engineer the only thing the engineer needs to really do is to get into R1. If you can get into R1, he can get into R2. If you can get into R2, and then he can get into R3. All right, he just has to hop around to get there. All right. So we went over telnet and SSH over in the previous chapters. And that's just, again, what it's just going over. This is just going over some of that. All right, well, that finished up that chapter. All right, one key to doing well. Yep. So it's just some key terms. We got ping, trace route, ICMP echo request, ICMP echo reply, extended ping, forwarding route, reverse route, and then DNS. All right. Yeah. Anybody got? So I'm super stoked up, guys. Super stoked because what we got next? We're finally out of chapter 5. Well, part 5. Woo! I'm so happy right now. Now, look, we're in part 6. OSPF. OSPF, we're coming, baby. We're coming for you. Open shortest path first. Open shortest path first. All right, OSPF is going to be pretty neat, guys. You guys have seen me configure OSPF probably a bunch of times. Like I said, I think I've actually talked about this a couple times. I have, again, my knowledge is I don't have. So again, when I say high and when I say low, high is I understand some of the fundamentals, but I don't have exact knowledge about every nitty gritty. When I say low level is nitty gritty knowledge. That's knowing everything. Okay, so when I say high level knowledge, that doesn't mean a lot of knowledge. That means that's pretty much like I'm looking down on something and I can just see the concepts and kind of understand the fundamentals of what I'm looking at. Okay, low level knowledge is when I'm standing in the muck of everything and I can see everything around me perfectly. Okay, so again, I have high level knowledge of OSPF, meaning I understand the principles and concepts and fundamentals and how to at least configure it. I don't have, mid level or lower level knowledge. Okay, so this is going to be very, very good for me to this is going to be awesome for me to get into. So part 5, chapter 19 is going to be understanding OSPF concepts. Part 20, implementing OSPF. And then part 21, OSPF network types and neighborship. All right. So it's going to be, first part of it's going to be comparing OSPF to other protocols like IGP. Does it mention? Let's see. Oh, so it's going to be going. So it's going to be going over some administrative distances. That's what we were just talking about earlier. It's going to be going over just some of the values of EIGRP, BGP, RIP, and stuff like that. Becoming neighbors, router IDs, and stuff like that. Elections. Yeah. So some BDRs and some DRs. So designated routers and then BDRs. What's the terminology for BDR? Is it backup routers? It could be backup routers. But we're going to be going and covering over that. That's mainly in chapter 19. 20 is implementing actual OSPF. So you got to remember when you're configuring and implementing OSPF, OSPF uses wildcard addresses, okay? Wildcard addresses. All right, not subnet mask address. It's a little bit different. It's similar, but it's a little bit different. It's like thinking of a subnet address in reverse, almost. That's at least how I look at it. So if you can understand subnet addresses, you can then just flip that concept around and think about wildcard addressing. Okay, but what we then need to talk about and think about is areas, because in OSPF you can identify areas. And if you saw a couple of streams, I forget now, it was a couple of streams ago, I had implemented stub nose areas. I just did it just to see if I could figure it out. And we created a topology utilizing OSPF and dynamically creating stub nose areas throughout our entire topology by just identifying. And all we did was we identified interfaces that had possible routing information off of it, and then that was dynamically it was like every router picked up on that information, and we were able to create huge detailed routing tables just off of identifying, again, just the interfaces that these possible networks resided off of. It was pretty awesome how it all played out, and it worked perfectly. Um, so we're gonna get into that. There's some interface summary commands. Um, yeah, so that's gonna be fun. Um, so yeah, so I'm pretty stoked. I actually can't wait. Like I've been so like this whole chapter, OSPF has been one of the chapters I can't wait to dive into. And then we have the old dreaded right after OSPF, we have IPv6. No, no IPv6. So yeah, then after that we have IPv6 coming around the corner. And like I said, after that, guys, we have wireless, wireless technology, wireless LAN technology to talk about, and then we're into the second book, guys, and then, like I said, from there the topics get a little bit deeper into some of the knowledge, but the thing is, what it's going to do. It's almost gonna bring things full circle around, okay? To kind of finish everything back off, because we're going to be talking about NAT. All right, we've already talked about NAT, but we're going to be talking more about NAT, network address translation. We're going to be getting into DHCP snooping, ARP inspection, implementing port security. All right, some good stuff, guys. I mean, we got some really some awesome stuff coming up very shortly, and these are topics that get into important ideas and important fundamental things as it relates to real world production stuff. All right. So we have some of that coming up. We have some. Yeah, I'm pumped up, guys. I'm pumped up. We've made it. We've made it thus far, dudes and dudettes. Ooh, and then we got some cloud architecture. I like me some cloud architecture. So once we get over to the cloud architecture stuff, guys, I have some stuff planned for us. Obviously, we'll be utilizing my server over here for some of that labbing. All right, for some of that labbing stuff. All right. We'll create another virtual switch. All right, we'll create a virtual switchy here. We'll create a whole entire cloud lab that we can do some stuff in. I'm gonna be up because obviously I'm used to working the overnights and I got the night off tonight. So I'm gonna be up late tonight. I might boot up another stream later on tonight, possibly, depending. Because I want to finally finish what I've been working on my Discord server, so that way I can get you guys just some more. So the Discord server would just be it'd be a cool place if you guys you're looking for extra information and stuff like that. And that'd be where I'll be putting up like the packet tracing labs that I'll be that I usually create. You can also, I'll have an area that you can pick up if you guys are into like Cisco Modern Lab and like that stuff that I use. You guys can pick up those XML files and stuff like that. Again, if you know how to do that stuff. I don't suggest, if you don't know how to do that stuff, don't waste your time with it, because you'd just be wasting your time. But the packet tracer stuff and all that stuff, you guys are, you guys should know how to just download and open up on packet tracer and whatnot. I'll be populating plenty of information in there, links and stuff like that to a lot of my sources, and I'll be looking for you guys out there to give me some sources and stuff like that to populate in there as well. The server though it's gonna be locked down, just because it has to be locked down, because I don't want there's gonna be rules, and I keep bringing this up. There's gonna be rules about how I want it to be on that server, just because I want it to be a place for people to learn and to have some fun. All right, I can't allow it. I don't want it to turn into just a free for all mosh pit of madness. Okay, because it can turn that way real fast on a Discord server. So I don't want that to be like that. There won't be no. It's going to be a total place for everybody. Everybody. There won't be no. There won't be no discriminating, no nothing at all. I will not put up with any of that stuff, guys. All right. I'm a person for everybody. All right. Everybody deserves to learn these technologies. Okay. So like I said, I'll probably be up late tonight, finishing up just a couple of things I got left at least I wanted to see on it and stuff like that. So hopefully that. I do have some college stuff I still got to do. I think I might try to catch up on some of that. I don't know how much I got. I got to check on what I got left for schoolwork to do on my end. I also got some. Maybe we'll do like a Photoshop. I'm all. Oh yeah. Oh, thanks for hanging around still. I'm going after my bachelor's degree in IT too at the same time. So I gotta start. Well, I do. You know what's funny? I study more on the CCNA. I've been so involved in doing these things, like I tend to forget about my actual college work at the same time. Which that is just important. I've just been so lucky the last 2 weeks we've had a vacation. But yeah. I go to it's online. It's university online. University online. University of Phoenix online. That's the college that I'm going to. I think it's great though. It's awesome. I love it. I don't know if any of you guys out there have ever gone to University of Phoenix. A lot of people have sent bad reviews about it. I think it's actually pretty awesome. It's great. At least it fits my life. You know what I'm saying? So yeah. Yeah. Yeah, that's about it, guys. I gotta get my kiddos. I gotta get my kiddos to beddos. And then I gotta spend. I promised the wife I was gonna spend some time with her tonight. She's gonna be home. Probably I don't know if she's still on the stream, but she usually gets home around 9 o'clock. So I promised her that tonight was gonna be a night that we'll spend some time together. But then after that though, because she'll be going to bed after that, and then obviously I'll be up. So I'll be on later. Most likely I'll be on later. But yeah, my new friend, Mr. Docspat, Mara Docspat. I appreciate you hanging out with me, and I appreciate everybody else. My YouTubers. There's been some consistent YouTubers on here today. Usually I don't get too many YouTubers, but today, shout out to all my YouTubers. Thank you very much for hanging out today, guys, guys and gals out there. And I've had a couple more Twitchers stick around all day today. So thank you very much, guys. I appreciate you guys sticking around. If you haven't, what times are my streams? So what I stream, it's Monday through Friday. I bounced up a half hour just to give me a little bit of a time frame, but it's Monday through Friday, 5:30 p.m. Eastern Standard Time. So wherever your time zone's at, it's 5:30 p.m. Eastern Standard Time, Monday through Friday. And I usually go to about quarter of 9 o'clock ish, because I have to be to work by about 9:30. And I usually, depending on my schedules, I'm now working like 6 days a week, which I stinking don't want to be doing. But it's it's whatever. It's making money. But yeah, so it's 5:30 p.m. Eastern Standard Time, and then on the weekends, I just tell everybody just to have your notifications on, because I usually pop in again if I'm working. It'll be later on in the night, or not possible, or not at all. But if I'm not working, I've been doing these new streams where I call them my in real life with Joe, my IRLs with Joe. where I'll do some cooking streams. I have some 3D printing stuff too that I got. My big sister and her fiance sent me over a 3D printer that they wanted to see me add to the stream. So I built it I think it was last week. I streamed it. It took me like 5 hours, and I streamed it. Took me 5 hours during a stream to build. I've never built a 3D printer ever, and these directions were awful because they were all in Japanese. So, but it took me about 5 hours to put it together. I still have it, but I could not get it to. We got it all together. We got it to run, but I could not get it to calibrate. Yeah, it's pretty cool. So we got to get it. I still got to get it calibrated. But I need to watch. I need to watch somebody else's YouTube channel to figure out how to get this thing calibrated, so I can get it up and running for the stream. So, so that'll be part. That's going to be part of things too as well here shortly. And again, I'm getting into all things creative and stuff like that. 3D printing, 3D rendering too. I do stuff in Blender, Photoshop, and stuff like that, artwork and stuff like that. So that's also going to be part of the Discord too as well. Some creative stuff too. And I would love to see everybody else's out there artwork. I just love artwork. Yeah, guys. Like always, I love every single one of you guys, and thank you so much. My new friend Docspat, Mara Docspat. I love that name. Thank you so much for that follow. Remember, guys, let me see. I'm only a handful of follows away from finally hitting my goal of 50 follows, guys. Get me across that board. Get me across that finish line, guys. I would love it. You guys pump me up. You guys are what's keeping me coming back every night for this, man. This has been an awesome stream. And I want to continue to bring this quality, bring this, continue to bring this to you guys. This journey's not going to end after I get CCNA certified, because we got to roll right into DevNet, and then we're going to be rolling right into CCNP, and we're going to just keep rolling, guys. All right, this is going to take us a couple of years to get through all this stuff. So, there's my Nightbot right there with my my streaming notifications for you too. So, I bid you guys a good night, and like I said, if you guys have any notifications on, I might, like I said, I'll probably be on later on tonight into the early morning, just because my body's so used to working the overnight. So, mwah! Hold on, let me get to my other screen here. Drop this down. Let me see if I got any other my fellow Twitchy friends. Let's play some music. Let's see who's on Twitch right now. Maybe we can go raid somebody. Who I got? Oh, I got my boy. All right, guys, do me a favor. Hang out. Let's go raid my boy. Bacon again. Guys, hang out for the raid. As we're gonna go raid my boy Bacon. He's a good dude. Yeah, we're gonna go say hi to my boy Bacon. All right, guys. All right, guys. I want to tell you guys, have a good night. I love every single one of you guys. Thank you so much again for hanging out with me tonight. All right, let's go say hi to Mr. Bacon.
It's toned down a little, but a little while ago we had some crazy shenanigans. It's good to see you, man, Mr. Martin. Joseph Caffarelli dropping me a raid again. Good to see you, man. Good to see you. That is 5 days of quality content, yes.
Oh, snap!
Raid again, my dude. Good to see you, dude. This dude just called me a copsucker? Cocksucker. Fair Oak, man. Thanks for stopping by, man. Good to see you. Take care of yourself, buddy. Fuck, don't you... Man, you guys are getting into some fucking here. Hello?
Fuck you looking at? Nothing to see here. Move along.
Is this how Night City's finest protect and serve?
Why? You want to be some kind of hero?
I don't care. I don't know.
So, why the fuck we talking?
I like to know what's going on around me. It's not every day you see a man in a 1,080 suit get beaten within an inch of his life. Wouldn't you agree?
Yeah. He put a girl into a coma. Daughter of a friend.
Ron
Yeah,
Skip for
Blips,
an
man,
XPD.
it's still pretty rough
Second
for
one.
me too. We just had a club fight where the frames were like probably 5 or 6 was when I was getting frames. It was
From what I can tell, your guy's a mid-level manager.
And?
The corp won't let this slide. They'll pull the data from this asshole's biomon and find you. And then, they'll shoot you.
You think I don't
That's
know
true.
that? Fucking corpos walking around like holy cows in a two-piece. But I ain't letting them go. No fucking chance.
I'm not asking you to. What I want is for you to let me finish the job.
Yeah? And what's in it for you?
Nothing. This is how I unwind.
All right. Let's go, boys.
Take care of yourself, officer.
go fuck yourself. You're probably gonna get banned again, yeah.
Rise and shine, Corporal Swine.
Shit. Wow. If it wasn't for you, I'd be... Well, thank you. Were you sent by the company?
Wrong answer.
Company D's nuts.
Then hold on. What do you want from me?
What did what did Felly say? Oh, you said she was getting deloused. You accused her of having lice and other things. Oh God. Oh man, you're fucked. Well, I can't get the money. I could use the street kid, or I've got 20 perception.
The
So
truth.
let's just
What do they want from you?
I have no idea. They said something about some slut and a virtue.
Halix is gone,
What
Felly.
what I had to do with it? They started beating on me so hard, I thought I'd die. This city's really going down the drain. For the police to do this in plain sight for
Dork.
no
Thanks for
reason.
stopping by and hanging out for a bit, man. Good luck with your stream. I'm sure I'll see you later.
Go on. Get out of here.
You just spit your beer